My name is Dusan Ranđelović, and I'll talk about this topic. The largest number of existing educational buildings on the territory of southeastern Serbia is obsolete in terms of energy efficiency, which gives a lot of opportunity for improvements and energy savings. Reconstruction and rehabilitation of existing elementary schools using the passive solar design systems would improve the energy picture of this sector. Starting from defining the geometry of building through its characteristics and internal and external influencing factors, it is possible to obtain the necessary data on energy consumption for heating and cooling. Awareness of the importance of improving energy performance is known to the general public, and the main question is how much insulation is sufficient and whether there are some systems that would provide internal comfort without additional energy consumption. Passive solar design is extremely important and is defined as a system that collects, stores, and redistributes solar energy without the use of mechanical systems. Passive use of solar energy is the basic and cheapest way to use energy from the environment. Some of the most popular passive solar design systems, such as double skin facade, trombe wall, green roof, and so, proved to be justified for the climatic conditions of Serbia. The behavior of the double skin facade is directly related to the orientation and climatic conditions, and it can be said that the greater the sun's radiation and its surrounding air temperature, the greater the final energy saving in the open ventilated facades. Any material that have a high thermal capacity can be used in the trombe wall. The high degree of heat accumulation has concrete, stone, earth, but also water, so they are most suitable for making such heating systems. The use of double instead of single glazing for trombe wall system not only reduces thermal losses in winter, but also improves passive cooling in summer. A green roof, or living roof, is a roof of a building that is partially or completely covered with vegetation and a growing medium planted over a waterproofing membrane. The higher the ratio of the roof surface to the surface of the entire building envelope, the greater the potential energy losses. Compared to the conventional roofs, green roofs improve building performance and reduce energy consumption for heating the building. Sailor developed the physical model of the green roof and integrated it into the energy building simulation program Energy Plus. Based on the American simulation study of primary schools in the city of Nišu, the following steps were undertaken. Identification representative example of the elementary school buildings in the city of Nišu, and a brief presentation of its technical characteristics, as well as the definition of the possible levels of energy efficiency improvement by applying passive design principles. The lack of reliable information related to the technical characteristics of the building, the way they are used, poor information and motivation of their users for improving energy efficiency makes the current situation even more complicated. Since the largest heat losses occur through the building envelope, it was necessary to perform architectural analysis. Based on the architectural analysis, we can see on these tables percentage share of the thermal envelope of analytical buildings depending on the orientation, as well as potential for application of passive solar design measures on simulated models. On this slide, we can see the appearance of energy models of simulated school buildings, as well as a percentage share of space types for each school building model. The simulation was conducted for a run period of 1 school year. In the performed simulations, we start from the assumption that constant internal temperature is maintained in each zone, and an ideal HVAC system has been adopted to provide thermal comfort. The internal gains are determined by the number of students and teachers and electrical equipment. For various space types, different number of people are defined, as well as an adequate degree of their activity and their presence during the day. Energy rehabilitation was carried out by intervention on transparent and non-transparent surfaces of the thermal envelope. Simulations were conducted in the software packages SketchUp and Energy Plus. Okay, so to determine the energy consumption by providing the necessary comfort, almost 14,000 combinations of considered measures for each model of school buildings were created and simulated, which in total gives more than 111,000 results. Parametric tree graphically illustrates the interventions and conducted simulations. You can see it on the right side of the slide. In addition to the baseline model, which is shown with A0, with index A0, there are 28 other variants of the model with all combined interventions and 27 with only passive solar design measures injected with different parameters, and the description of the list of all applied alternatives that were varied are given in the table 5. The highest recorded values of heating energy consumption compared to the baseline model in percentage for conducted simulation are shown in table 6, and as you can see, the highest energy savings were achieved for energy refurbishment of building envelope, plus adding ventilated trombe wall and green roof, while for only applying passive solar design measures, the highest energy savings for heating was achieved by applying trombe wall and green roof. On this table, we can see the highest recorded values for cooling energy consumption compared to the baseline model in percentage for conducted simulations. And you can see that the best energy savings for cooling are achieved by applying a double skin facade and blind, even for combinational measures and only for passive solar design measures. Sorry. Okay. Comparative analysis. Okay. On these scatter plots, you can see this comparative analysis, and they show the distribution of building heating and cooling demands covered by the models used in this research. The distribution showed the trade-off pattern between heating and cooling demand, which is commonly seen in the real building. For example, buildings with both low heating and cooling demands are possible if HVAC operations can be improved by employing free cooling and a night ventilation strategy. Poorly insulated buildings show higher heating and lower cooling demand due to infiltration, while well-insulated buildings tend to show lower heating and higher cooling demand. On the other hand, buildings with both high heating and cooling demands, the empty area in the upper right quadrant, are less likely to happen in the mild climates. As you can see, the uncovered area on these scatter plots are due to parameters of energy refurbishment of building envelope. A comparative analysis of the implementation of these passive systems in the model primary schools for a period of 1 school year showed that the application of some interventions can lead to undesirable consequences. For example, some interventions provide savings in energy consumption for heating, while cooling energy consumption has increased relative to the initial model. Of course, in some scenarios, a reverse situation is possible. If we talk about alternatives that lead to maximum energy savings for heating and the highest cooling demands, they're without blinds, while thermal envelope is always well insulated. Alternatives with blinds, where thermal envelope is always well insulated, led to the lowest both heating and cooling demands. Alternatives without blinds and with no insulated thermal envelope led to the highest both heating and cooling demands. Alternatives with blinds with bad insulation of thermal envelope led to the highest heating and lowest cooling demands. If we talk about alternatives on the baseline model, without any of the energy refurbishment of building envelope, implementation of double skin facade with better glazing plus green roof led to the maximum energy savings for heating and the highest cooling demands. Addition of double skin facade with better glazing with blinds and green roof led to the lowest both heating and cooling demands, which confirms that the blinds can greatly affect the final energy consumption. Alternatives with only trombe wall led to the highest both heating and cooling demands, while the addition of blinds or blinds and trombe wall leads to the highest heating and lowest cooling demands. Implementation of green roof and blinds, double skin facade blinds, green roof, and trombe wall blinds and green roof contributes to significant savings in heating and cooling energy demands in both energy revitalized and baseline model, which confirms that the efficiency of green roof is more significant in buildings with modest insulation or those without thermal insulation. Most of the results of building cooling demands for all simulation are less than 15 kilowatt-hours per square meter per year, while most of the results of building heating demands for all simulations are between 50 and 80 kilowatt-hours per square meter per year. In summary, we can conclude that for analyzed climatic conditions, the application of passive solar design measures is justified also in terms of energy savings for heating and cooling of primary schools, which is confirmed by the obtained results of numerical simulations. For variants with an adequate application of energy refurbishment of building envelope, the application on trombe wall and green roof, and the combination of trombe wall blinds and green roof can lead to the best ratio of energy savings for heating and cooling. When it comes to implementation of passive solar design measures on a baseline model without energy refurbishment of building envelope, applying trombe wall, blind, and green roof, as well as double skin facade, blind, and green roof can lead to the best energy savings ratio for heating and cooling. The same combination of alternatives with or without blinds can lead to completely different results. Although the application of trombe wall, double skin facade, green roof contributes to significant energy savings for heating and cooling, the best results are only achieved when these measures are combined with energy refurbishment of building envelope measures and blinds. The practical applicability of the obtained results is reflected in the establishment of methodological and systematic framework for the management of energy performance improvement measures in the process of comprehensive revitalization of primary schools. Thank you.